Welcome back. In today's session, I'm going to teach you everything you need to know about interval and amplitude measurements. There are a couple of diseases where measuring makes a lot of sense and will lead you to the right diagnoses, like in ventricular hypertrophy, in bundle branch blocks, or other conduction problems. On the other hand, there are a lot of diseases where measuring is not necessary in order to find the right diagnoses, like in myocardial infarction, ischemia, or various rhythm disorders. And then there are situations where the beginner has to measure, but the expert does not, because she has an eye for it. She has looked at so many ECGs that she knows exactly when amplitudes and time intervals are off. In this section, you'll learn how to perform correct measurements on the ECG curve. So let's jump right into this simple and straightforward skill.
This is the standard grid of the ECG paper. This grid has large boxes and small boxes. Each side of a small box is 1 millimeters in length, and each side of a large box is 5 millimeters in length. On the ECG paper, you can measure in 2 dimensions. One dimension, the y-axis, is measuring millivolts. The other dimension, the x-axis, is measuring time. Let's have a look at the millivolts first. 1 millivolt corresponds to 10 millimeters, so 2 large boxes in length. From here to here, you have one large box of 5 millimeters, and from here to here, you have another large box of 5 millimeters. So 10 millimeters in total, which equals 1 millivolt. Next, let's look at the time axis. Most ECGs are written at a paper speed of 25 millimeters per second. So the distance from here to here corresponds to 25 millimeters or 1 second. As you can easily see, this 1 second consists of 5 large boxes. So one large box therefore corresponds to 1/5 of a second or 0.2 seconds. One large box or 0.2 second segment in turn consists of 5 millimeters. So 1 millimeter corresponds to 1/5 of 0.2 seconds, or in other words, 0.04 seconds. So here's what you have to remember. 25 millimeters correspond to 1 second, 5 millimeters correspond to 0.2 seconds, and 1 millimeter corresponds to 0.04 seconds. When you start to measure, you always have to start at the isoelectric line, which is here. So when you measure amplitudes or millivolts, you'll always start at the point on the ECG where the curve leaves the isoelectric line. So when we want to measure the amplitude of this S wave, we measure from here to here. From here to here. When we measure time intervals, we also start at the isoelectric line. So the interval starts at the point where the curve leaves the isoelectric line, which would be here for the P wave, until the curve comes back to the isoelectric line, which would be the P wave duration, as in this case. The same holds true for the QRS complex. It starts to deviate from the isoelectric line here, and it comes back to the isoelectric line over here. That's when the QRS complex is over, which would be the QRS duration. Let me show you a quick trick when measuring time intervals. Let's say you'd like to measure the duration of this QRS complex. First, we put a piece of paper here. Then we mark the beginning of the QRS complex and its end. Once you mark that down, you can put the sheet of paper to the beginning of a large box on some free space of the ECG paper, and you count the number of small boxes until the end of this interval, which would be 1, 2, 3, 3.5 boxes. Since each little box corresponds to 0.04 seconds, 3.5 times 0.04 equals 0.14 seconds. Pretty easy, isn't it? Next, let's talk about the duration of the PR interval. The PR interval starts at the beginning of the P wave and ends at the beginning of the QRS complex. It represents the time the atrial depolarization takes to travel through the AV node in order to reach the ventricles.
And finally, one more interval, the QT interval. It starts at the beginning of the QRS complex and ends at the end of the T wave. So I hope everything was clear. If not, rewind this video and watch it again. Otherwise, please go through the exercises and perform the measurements yourself. You can either do the measurements on the screen by counting the boxes and calculating the time intervals or amplitudes, or you can print out the PDFs and do the measurements on paper or use your workbook. Either way is fine. So do this important exercise now, and I'll see you in the next session.